Today I'd like to give you a summary of sine, cosine, tangent, and cotangent thus far as of what we've already learned. Okay, so this chart might be helpful later down the road to help you be able to put everything together. So looking at sine and cosine, think about the domain as like the x values. Okay, so since we're plugging in radian values, we can plug in any radian value all the way up to infinity and negative infinity. So for both cosine, it's all reals. So I'm going to write this in interval notation. So from negative infinity to infinity. Okay, now the range for both, as you can really think about it, at top, the highest is going to be 1, and the lowest is going to be negative 1. Okay, so I'd write bracket negative 1 comma 1 bracket, and the same thing for cosine. Okay, zeros for sine, if you think about every time it happens, okay, for sine it's going to happen every pi. So I would say pi times a number n to represent n, as n any is a real number. Okay, being any real number that you plug in for n, you'll get a value of pi where you get 0. Okay, for cosine, that would just be shifted over to be every pi over 2 or half pi that you come across on the unit circle. But since you're starting at pi over 2, the length in between each one, so the next one would be 3 pi over 2, or if you're going the other way, it would be negative pi over 2, so they're a distance of pi away. So you could say plus pi times that n value where n is a real number. Okay. Now sine and cosine don't have any asymptotes, so we can say not applicable, or they don't exist, or none. Same thing. Okay. For sine and cosine, your period is 2 pi. Okay. And for your amplitude, it's the absolute value of a. Okay. Then for tangent and cotangent, okay, now here you're going to have all real numbers, so you can say you may have to put this one in words, so all reals, or how about we do x, so all real numbers, except, remember there's asymptotes for this one, so you're going to have every pi over 2 that happens, or half pi, but that's kind of like this cosine where a 0 happens every half pi, but they're a distance of pi away from each other. Okay, where n is a real number. So plugging in a number like 5 times pi plus pi over 2 on the unit or on your graph, you will find a asymptote there, so we want to exclude those. Okay, cotangent is the same kind of thing, except the asymptotes don't have n on half pi's, they have it on whole pi's. So we can say except where pi is times n. Okay, now we're actually adding 0 to that, but we don't have to say that since 0 plus pi over n is the same thing as pi over n. So we can just avoid looking at that or writing it. Okay, our range is unlike sine and cosine, where we can go from top to bottom all the way up and down. So we get to say from negative infinity to infinity for both tangent and cotangent. Okay? Now this is where our zeros and asymptotes come in. Let's write our asymptotes in since we already kind of have the framework. We already talked about the asymptotes for each of these because that's what we're excluding from the domain. So we can say pi over 2 plus pi times n for our tangent, where n is a real number. And the same thing for cotangent, but we can say pi times n, where n is a real number. Okay. Then for our zeros, okay, for tangent, we get a 0 every whole. Okay, so it's remember it's kind of like the opposite of cotangent. So where you get an asymptote for cotangent, you're going to get a 0 for tangent because you're doing 1 over 0 for tangent or cotangent, and then you're flipping it around for tangent. Okay, so here I get pi over n, where n is a real number. Okay, and then since it's flip of cotangent or a flip of tangent, cotangent will have pi over 2 plus pi times n for every 0. So like at the half you get a 0, at 3 pi over 2 you get 0, and n is a real number. Okay. Now for the last thing, tangent and cotangent both have a period of pi. Okay. Now all of these have the same thing in common, where the amplitude is the absolute value of a. Okay. Now this is just something for your notes, just to have to kind of put everything we've kind of learned together in one spot, just so you can kind of piece all these functions together. Later on we'll be doing the same thing for secant and cosecant, and so then make sure you leave space underneath this chart where we can add those two values. Okay? Have fun.